This is Analyzing Functions with Steven,
Jacob, Stefan,
and Carter.
In this video, we will show you how to analyze a function. In this first clip, Jacob will show you how to find the domain, range, zeros, and x and y intercepts of a function. Now, if that didn't make any sense, I'll give you some definitions. The domain includes the x values of a function. The range includes the y values of a function. The zeros, or x-intercepts, are the points that touch the x-axis. The y-intercepts are the points that touch the y-axis. Now, if these words still do not make any sense, the live demonstrations will help you understand. Now let's get to it.
Okay, here's an example of analyzing a function. We have the order pairs -1, 2, 2, 3, 0, 1, and 3, 0. And first we need to find the domain. The domain, as we learned before, is the x of each ordered pair. So we have the domain is -1, 2, 0, 3. Alright, now the range is the y value in each ordered pair. So we have 2, 3, 1, and 0. See, if these repeated, we would not repeat the thing in the set. So let's just say this ordered pair was 0, 0, and the ranges were the same. We should not repeat the 0 twice. Alright, zeros. Zeros, as we learned before, were just the x-intercepts. So let's look at our ordered pairs, and we have 1, 0, 3, 0. So we just put this down. Alright, intercepts. That's pretty self-explanatory. So we have two intercepts, an x1 and, an x-intercept and a y-intercept. So we're just going to put this down. Now, is it a function? One way is to find out if it's a function is to see if any of the x values repeat. Or we can graph it and use the vertical line test. But let's use the first way. So let's see if this repeats. This doesn't repeat, this doesn't repeat, this does not repeat, and this does not repeat. None of these repeat, so we say yes, because they don't repeat. Alright, now we can graph it. So, -1, 2, 2, 3, 0, 1, and 3, 0. Alright, this is an example.
As Jacob explained, you can determine if a relation, which is a set of ordered pairs, is a function using two methods: seeing if the domain repeats, and using the vertical line test. In this next clip, Steven will demonstrate how to use the vertical line test, and he'll give you a multiple choice example of analyzing functions you might see on the SOL.
Hello, my name is Steven Smith, and I'll be going over some multiple choice questions you might see on the SOL on the topic of analyzing functions. Now let's just start. The first question asks, what is the domain of this set of ordered pairs? 2, 1, -3, 2, 7, -1. Okay, so to find the domain, you have to find the x values. Now the x values are the first one in each set of ordered pairs, so they would be this one, and this one. So now let's look at our answer choices. So there's 1. Do we see a 1 here? No, there's no 1, so you can just X that out. X that out. And then for B it says 2. Do we have a 2? We do have a 2. Do we have a -3? We do have a -3. Alright. We have 7. Okay, we have a 7. So let's just put a question next to there because we have to read all the answer choices. Now number C, it says 2, 1. Do we have a 1? We do not have a 1. The 1 is the y value. It is not the domain, so we X that. Now do we not have a domain? Well, we have an x value, so there is a domain. So it has to be B. Alright, let's go to the technology enhanced question. it says, use the vertical line test to prove if this is a function. Now, the vertical line test is a test to find if something is a function, if something has repeating x values. So what we do is just draw a vertical line, seeing if any of the x values repeat. So if there was like -5, -5, 2, and then -5, -2, it would be right here, and then the vertical line test would say that's not a function. So let's just draw a straight line through this one. Alright, we got an intersection here, and we got an intersection here, which means this is not a function. Sorry, that's probably bad handwriting, but you know.
Now, to help you understand this concept a little bit more, I'll give you some more multiple choice examples you might see on the SOL. Alright, so here are some more multiple choice examples. So the question asks, what are the zeros of this function? And the function is f of x equals x plus 1, x minus 3, and x plus 2. So, to find the zeros of a function, you have to set the function equal to 0 and solve for x. So x plus 2 equals 0 would be x equals -2 because you just subtract it over to this side. So basically, a good way to remember it, or a good way to do it at least, is that you can do it in your head. If this is negative, it'll be positive. If this is positive, it'll be negative. So
I'll send that schedule out in a little bit.
you have to find.
All right, thank you.
All right, and then it's not ever going to be y equals. It's always going to be x equals. So these two are canceled out. And then all you have to do is find -1, +3, and -2. So this one has the exact opposite, so that's not it. So it's C. Now, the next multiple choice problem. What are zeros? And I basically just explained that in the first one. So they are x-intercepts. Remember, not y, x-intercepts. And these have been more multiple choice problems. I hope this video has improved your understanding of analyzing functions. Thanks for watching.